My name is Karina Zander. I'm from Axayo Software. There I'm responsible for marketing and sales. We are a German-based company, a developer of different extensions, plugins to different Adobe layout applications, but about this I will speak later on. So the idea of my presentation is to show you how to handle with structurally complex content in the world of accessible PDF with the example of mathematical formulas. So there is other complex content in accessible PDF, but yes, math can be seen as a very complex one. So my presentation is divided in three main parts. In the first part, I will give you an overview or a feeling of what is meant by simple and not so simple documents apart from PDF. In the second part, I will come to PDF itself, so to complex content in accessible PDF. And in my last part, so in the third part, we will have a closer look on mathematical formulas as an example of structurally complex content, what problems can occur here, and how we can handle them. Yes, simple and not so simple document. So first of all, what are documents? Documents are, so to speak, curated final form of content. So this is nothing you would have said like this and written it down, but you have thought about it, what to include and what to not include, and then this document has a special state. And documents are mostly there to be shared with each other or with yourself too. So if you have written something down and you would like to look into it on a later date again. But what I need for an accessible document? So I first need to assign text for each piece of content. So a description of the role this special text element, as for example the paragraph or the header or a cell has in this document. All these text elements have to be structured in a tagging structure, so in a tree structure, so to know in which order they are in this document. And for all non-text content, as graphics, images, a logo, for example, there has to be a text equivalent, so an alternate text description. Yes, but so let's have a closer look on documents. Most of the documents following a linear structure. So one piece after the other, and or there are also chunks of linear content. I have here some examples. So, for example, a letter usually starts always with a name, then with a salutation, with the content of the letter, and so on. So you read it usually from top to the bottom. The same applies here for such a novel or a simpler form. So as said, you always read it from the top to the bottom, so clearly linear content. There are chunks of linear content, as you can see here in this newspaper. So there are different articles. So the layout is maybe not linear, but each article follows again linear content. The same here for such a page of a catalog. You have parts which you can read, which you are reading from left to the right, but mainly you are reading it from top to the bottom again, so even that the layout is not linear, the reading order is it. Yes, so after we've understood what is meant by linear content, how it could look like further. So there are different forms of complexity in that context. Starting with mild forms of complexity. So, for example, with nested lists or table of contents, so where the content is not completely linear anymore, Yeah, for example, also for cross-references, so this is a connection between two positions, yes, where you have to jump back and forth, so it is not linear anymore. Here are also some examples, an example for a nested list, for example, or a table of content, which is a kind of a nested list. A footnote, what is a kind of branchings, or an easier table, which consists only of columns, or such a restaurant menu plan, yeah. So it is linear, but yeah, here in this restaurant menu you can jump into an entry and go from left to the right, so it is not completely linear. But yeah, these were mild forms. But we can carry on with the complexity, with tables which are not so simple anymore, or with simpler math expressions, org charts. Also here, such a boarding table which consists of multiple columns and rows. Yeah, so you have to find out which columns belongs to which cell, or such an easier math expression. Yeah, you can read it in linearly, yeah, but the structure is not linear anymore here. Or that org chart, which follows a tree structure. Yes, but this wasn't so complicated. It still gets more complicated with highly complex tables, so very, very complex tables with mathematical expressions, which are not simple anymore, with flowcharts. So imagine such a bus timetable. Yeah, it's even for me difficult to catch up where I have to find what, yes, and what about a screen reader, or such an org chart, which is, yeah, it's obviously that here is nothing linear anymore. Or a metro plan, street map, such a more complicated math formula. So where I will start, yeah, and how the screen reader should know, yeah, from where to read and which structure to follow. Also imagine such engineering drawings. Yeah, so this all were static complex contents, but now would be the question how to include this content, or how to represent it in accessible PDF. So what is quite well covered already through TeX PDF are lists and tables. So this is achieved via generally understood predefined tags, tag attributes, and the tag structure. So the tags, for example, I need for a table are the content table, a header cell, a content cell, and yeah, and the tag attributes define if a header cell relates to the row or to the column or to a special cell. And all these parts have to be held together through the text structure. And the same applies for lists. But what is not so well covered in accessible PDF so far are diagrams, charts, technical drawings, and math. So we can't help so far with diagram charts and technical drawings, yeah, but we have some ideas on the math aspect in accessible PDF. So how we could do this? We could say, let's use MathML tags. So MathML is maybe the best way to map accessible, to map mathematical formulas somehow accessible. It is part of PDF 2.0 and can somehow be used in PDF 1.7. So we could assume the problem is solved, right? But yeah, what's MathML at all? MathML is an XML syntax for mathematical expressions. It is part of HTML5 and is mentioned also part of PDF 2.0. So this is how it would look like. So a simpler formula, this square root of 9. So on the left side, this is a good representation of what sighted people would capture with its eyes. But from our point of view, MathML tags can't help that much. You can do it, it works, yeah, but it doesn't help so much as there are almost no creation tools, so no tools which can lift it over into PDF. And there are no tools, or almost no tools, which could lift it out again from PDF to make it somehow usable. And there are no support in assistive technology, so there are no screen readers which support MathML. There is somehow MathML support in HTML, but from our point of view, yeah, this is kind of patchy, not consistent, and yeah, there can be other opinions on this, but this is our opinion. And furthermore, so we were thinking if there are alternatives to MathML. There is, for example, ASCII math and LaTeX as native PDF format. And we were thinking, should it be the only right approach which we have to deliver? Or couldn't we combine concepts to serve the users? So what about providing options in different ways or for different needs? And does have to be math in the PDF syntax at all in the tag PDF? And what about to leaving the native content, the math in its native math format, and to count on that they are being native math players? But what there are for formats of native math? There is MathML, there is LaTeX, there is ASCII math, and a translated spoken version. So just I would read it and would written it down, yes. But I don't want to go into detail for this. There are also other formats. Yeah, and what native math players exist already? So there are Math Player, a plugin which can support MathML. There is Math Cloud, which can convert ASCII math, MathML, LaTeX into to SVG, PNG, and MathML. So it's an open source file. There is MathJax, which is a library based on JavaScript, which supports MathML, LaTeX, and ASCII math on a browser. And there are different screen readers, for example, NVDA, VoiceOver, JAWS, ChromeVox, Orca on Linux, which good or less good support in HTML and EPUB, but just not in PDF. So, and another thing we have to take into account is that some users are maybe fine with the raw math, yes? So, for example, LaTeX is often used in the scientific environment by math students, for example. They work daily with LaTeX, so they even think in LaTeX. For them, it would be very good to deliver LaTeX code, yes? Yeah, but how to offer access in PDF for this? So we have the native math, MathML, LaTeX, ASCII math, but there can be also other formats here. And there is the translated spoken math. So where to put this into PDF? So there are different options, which you can see here on the left side. So we could say, we could take the alt attribute on the formula tag, The formula tag is only visual stuff, so you can't do anything with it. But you could say to include the transliterated spoken math into the alt attribute, so to type text into it. Or even to take, for example, the LaTeX on the alt attribute, so the LaTeX code. So as said, for somewhat this will be fine. For another, I don't know, a pupil or a reader of a newspaper, this would mean a catastrophe, yes. And a further option would be to insert actual text for each sign of a formula, of a mathematical formula, yes. So the advantage here would be that you could decide to hear each piece, each sign on a special position of the formula. With the alt attribute, you can only let read everything or nothing. When I'm going further on my options, we could also include annotations where we highlight the formula and insert sticky notes or pop-ups, with a hint, regardless of what else I'm doing with the formula. For example, I could take the ASCII math, the LaTeX, and the MathML and the text representation and put it into the sticky note, or even to have an own sticky note for each variant. I even could start to embed for each or all formulas a file. Yes, so for example, a small text file including the translated spoken math. Or I could even take the MathML as an XML file and embed this into PDF. So again, for math students, for example, this could be a very practical way to open this XML file in another program maybe he uses. So as you can see, there are different options and different needs. And the main or the most important thing is that we should think of what the user needs, and what the special reader needs for math content. So when thinking of embedding math, you can embed any form or even a combination of them. For each formula, for example, you can embed a file, so in the context one by one, or even without assignment to the formula, or even all formulas combined in one file, So there are different options. But to better imagine how this would work in practice, I have here some examples for you. So this one is starting from LaTeX. So there is one project of Professor Ross Moore from the Macquarie University in Sydney. He developed a set of extensions for LaTeX, and also Professor Moore is following the mix and match philosophy here. So he uses options for MathML and LaTeX. So he uses embedding files, annotations. He even uses MathML tags in the PDF tagging structure. Yes, so let's see how this would look like in LaTeX, so math from LaTeX. So so this is the formula, a very complex one, and this would be the LaTeX code. So this would be how it is written, and this, you could take and put into the text, into the accessible PDF. So the second example uses MathML tags in tagged PDF. So this one is created using Ross Moore's set of macros. In this example, the tags are injected easily into the PDF tagging structure. So on the right side, you can see the different parts of the formula, and on the PDF tagging level, he uses the MathML tags. So the main tag is here math, including mtable, row table, and so on. But if you even don't work with LaTeX, but with Adobe InDesign, here is a further example. So if you have to generate accessible PDFs from InDesign, there are other options. So InDesign itself has no native way to represent mathematical formulas, so there is no native way to insert them synthetically in the PDF. So if you want to do it correctly, you need to use external solutions, so there are plugins. And one plugin which exists is Math Tools from Movement, which can handle mathematical formulas in InDesign, but this is only limited to the typesetting, so to a visual representation of the formula. And to improve this situation, the developers of Made2Tag started a cooperation with Movement and Math Tools. So Math Tools is doing good typesetting, and Made2Tag will take care on the accessibility part. So with Made2Tag, we will inject accessible representations based on Math Tools math objects into the exported tagged PDF. So this is the Math Tools, how it looks. With Math Tools you can create math formulas by choosing math operators and filling them with values. And so this is how the UI looks like of Math Tools. And in an upcoming version of Made2Tag, we will include a further task to configure the math export into tagged PDF. So this is the first UI of this part. So as you can see, you will have different options to choose from, how to include this math content into the tagged PDF via an alternate text, or you can include a highlight annotation including the math, or a sticky note. So all the options I've explained before. And here you can see what would be the result. So in the middle, you can see the PDF with a highlight annotation. Here on the right side, you have the annotation, which contains the MathML for the formula in the PDF. And on the left side, you would have the attachments, including the embedded LaTeX file, or it could be another file to ASCII math, for example. Yeah, so I'm coming to the summary of my presentation, so a summary of all you have heard. So as we've learned, to generate an accessible document, you need to assign tags for each piece of content. You need to organize them in a tagging structure so that they are held together. And for all non-text elements, you need text equivalence, so an alternate text. But if your document includes mathematical formulas, you need options on top. So optionally and additionally, we would say, not either or all. So the one, the other, or both. So you can insert more than one type of representation in PDF. You can embed one or more alternative representation, but the main question from our point of view is always who I want to serve. And if it's really necessary to start discussing if there is the real one correct approach, which would mean it would be from our point of view, but not to wouldn't it be better to look what our different target groups need? So who I want to serve is the main question. Do I want to serve pupils in school? Do I want to serve a reader of a newspaper, or someone in popular science, or a math student? So We think we should deliver more than the one only option, which we think is the best one. As of what we have learned, that for any situation it could be different. And yes, so this is our opinion on that mathematical formulas content in Accessible PDF, and tools are coming your way. So from the Axaya point of view, there is still nothing ready so far. We hope to have a version of Made2Take, including the math export option late autumn. So if someone is interested in beta testing it, can contact me. And if someone would like to learn more about LaTeX, can of course also contact Ross Moore in Australia. The contacts are also in the internet. Yeah, so thank you for listening, and I hope I could give you somehow a good overview of this part. Thank you.